Good morning, friends. Welcome back. In today's session, we'll be studying problem number 2 on numericals on columns. So, let us begin with the video lecture. A 3-meter long hollow column. So, this is the specialty of the problem. The column is hollow, right? A 3-meter long hollow column with inner to outer diameter ratio of 0.8 carry a load of 140 kilonewton. One end of the column is fixed and other end is hinged. Determine the diameters of the column cross section. Take allowable stress as 320 MPa and Rankine's constant as 1 divided by 7500 and factor of safety as 2. Right? Now, first let me write down the given data and then proceed further. So as usual, first let me draw a line here. I'll be noting down things. L is equal to 3 meters, so that is 3000 mm. Then inner to outer diameter ratio, so you can take it as di to d naught ratio is 0.8, right? So what you can write here from this, di is equal to 0.8 times d naught. End condition is one end is fixed and other end is hinged. One end is fixed, other end is hinged, right? Then allowable stress, that is sigma c, is 320 Newton per mm square. Rankine's constant A is 1 divided by 7500. So this is 7500, right? 7500. FOS is equal to 2. Now, with this backdrop, I have been asked to calculate the diameters of the hollow column. Right, so let me start with the solution. So here, first let me calculate the effective length for the given end condition. For the given end condition, how you calculate L effective? L effective is L divided by root 2. Right, so what is the value of EL? It is 3000 divided by root 2. So what is L effective? Let me check. It is 3000 divided by root 2. I'm getting it as 2121.32. 21.32, and it will be in EMM. That is the first calculation that is required. Then I calculate the moment of inertia. So moment of inertia is given by, it is a hollow column. So for hollow column, how do you calculate? It is pi by 4 d naught raised to 4 minus di raised to 4. Pi divided by 64 d naught raised to 4 minus di raised to 4. Pi divided by 64 d naught raised to 4 minus di raised to 4. Right, so that is the value of I. So if you just calculate, it is pi divided by 64 as it is. Put a bracket. D naught raised to 4. What is the value of D naught? It is unknown. Minus di is 0.8 times D naught. 0.8 times D naught raised to 4. Right, so this, if you just resolve this, I'll be getting the value as 0.0289. 0.0289 0.0289 d naught raised to 4. I'll be getting the value of moment of inertia in the form of d naught raised to 4. So once if we get this, then let me calculate the design load. Let me calculate the design load. So we know that FOS is equal to maximum stress divided by maximum stress divided by allowable stress, or you can call it as working stress. Some people also call it as design stress, right? So you can just alter this. You know that stress is directly proportional to load, so you can call it as maximum load divided by working load, right? Why I have done this? Because when area is constant, sigma is equal to P by A. So if A is constant, sigma and P will be directly related, right? So though both are directly proportional, so maximum stress can be expressed in terms of maximum load, working stress can be expressed in terms of working load. So FOS given to me in the problem is 2. Maximum load, what is maximum load? Maximum load I have to calculate, so I'll keep it as it is. What is working load? So working load given to me is 140 kilonewton, right? 140 kilonewton. So it is into 10 raised to 3. So therefore maximum load, since he has given the Rankins constant, it is clear that we should use the Rankins formula. So the maximum load in this case is nothing but P. So that should be equal to how much? It should be equal to 280 into 10 raised to 3 Newton. 280 into 10 raised to 3 Newton. How? 140 into 2, it is 280 into 10 raised to 3 Newton. Right? So once if this is done, now I'll be using the Rankins formula. Okay, other prerequisites before I use the Rankins formula, what are the prerequisites? First one is I'll be calculating area of cross section, which is pi by 4 d naught square minus di square for a hollow column. So it is pi by 4 d naught square as it is. Di is 0.8 times d naught the whole square. So therefore what is AC? Let me check this. So it is 0.8 the whole square, 0.8 the whole square. That I need to minus from 1. So 0.36 into pi divided by 4. So I'm getting 0.2827 d square. So it is 0.2827 d naught square. Then the other thing required is radius of gyration. It is given by square root of I divided by A, right? I divided by AC. So it is square root of, what is the value of I? Value of I in terms of d naught is 0.0289 d naught raised to 4 divided by 0.2827 d naught square. So therefore value of k will be, so let me check, 0.0289 divided by 0.2827, right? And square root of this. So it is 0.319 d naught. I am getting it as 0.319 d naught. 0.319 d naught, and it is once again in mm. Right? Now I'll be using the Rankins formula. So from Rankins formula, we know that P is equal to sigma C into AC 1 plus A into LE divided by K the whole square. Right, so we know that this is the Rankins formula. Now here the value of P is calculated. So value of P, you need to take it as 280 into 10 raised to 3 newtons. Value of sigma C is given to me in the problem. He has mentioned that as allowable stress. So that is the critical stress or allowable stress, it is 320. AC value is 0.2827 D naught square divided by 1 plus value of A is 1 divided by 7500. LE, L effective is 2121.32 divided by value of K is 0.319 D naught. This thing you need to square, right? So now you simplify and try to formulate what is D naught. So once if I substitute everything in terms of D naught, then I need to simplify. Simplification here is a bit difficult, but a very important problem from your exam point of view. So let us go ahead and step by step let us check out how I have simplified. So this one, the bracket quantity, if you just simplify this 2121.32 2121.32 divided by 0.319, this I need to square, so I have squared that. Then I need to divide it by 7500, so I am getting 5896. So that is how I got this 5896.16 divided by d naught the whole square remains in the denominator, right? Now I'll take the LCM here. So if you take LCM 1 into d naught, it becomes d naught square plus 5896.16 as it is. This denominator goes to the numerator. So it is d naught square and another d naught square. So it has become d naught raised to 4. I repeat, d naught square multiplied by 1. I am taking the LCM, so it is d naught square plus 5896.16 as it is, divided by d naught square. Instead of writing divided by, I have taken it to the numerator. So this d naught square multiplied by another d naught square, it has become d naught raised to 4. On the left hand side, it is same 280 into 10 raised to 3. Next, you cross multiply these two things. So you'll be getting an equation 280 into 10 raised to 3 d naught square. Then you multiply 280 into 10 raised to 3 into this value 5896.16. So in that case, I'll be getting 1.65. You can just check out 1.65 into 10 raised to 9. That is what I have taken here. Is equal to 90.464 d naught raised to 4. Right, now I need to solve for d naught. So what I am getting here is, I have written the same equation. I have taken all the terms on one side and I have equated it to 0. Problem here is I am getting a fourth order equation d naught raised to 4, यहाँ पे d naught raised to 2, and you are having a constant. And the problem with FX 991 EMS calculator, right, the one which is permitted for engineering students, in that it is very difficult to calculate the fourth order equation. The maximum thing what we can calculate is third order. Some people are having FX 991 ES, उसमें वो facility available है, but I don't think so whether it is permitted by most of the colleges. In 991 EMS which students use, उसमें ये facility नहीं है. Then how you are going to tackle this? So what I have done, 90.464 जैसे कि जैसे रख दो. D naught raised to 4, you can write it as D naught square, the whole square. So minus 280 into 10 raised to 3 D naught square, and this constant keep it as it is equal to 0. So I have converted a fourth order equation into a quadratic equation. Right, so this is x square, this is x, and this is constant. So this is ax square plus bx plus c is equal to 0. So I have reduced this into the form of a quadratic equation, and you know how to calculate the roots of a quadratic equation, right? So it is root is equal to minus b plus or minus b square minus 4ac divided by 2a. This formula is very popularly known to all of us. So then we need to put the values. So here x value, kya hai x value? This is x value. This is x square value. So what is x value? X value is d naught square. So x value jahan pe hai, that place you put it as d naught square is equal to minus b. So minus sign is already there, and once again you are taking minus, so minus into minus it becomes plus 280 into 10 raised to 3 plus or minus under root b square. So b is having a minus sign, so it is minus 280 into 10 raised to 3 whole square plus. Why I have taken plus? You are saying, sir, here you are having minus. So let us proceed further and check out. 4 into value of a. What is value of a? Value of a is 90.464. 90 point, and you are having 64. Next, C value is negative. It is minus 1.65 into 10 raised to 9. So that minus into this minus, it becomes plus, right? Divided by 2 into a. What is the value of a? Value of a is 90.464. So that is 90.464, right? So you simplify this entire thing, then you will be getting 822.57 into 10 raised to 3 plus or minus divided by this value. Now if you just check out, 10 raised to 3 is common and 10 raised to 3 is common. In both the cases you are having 10 raised to 3. If you take this as minus, then the numerator will be minus, right? And our common sense says that diameter cannot be a negative value. So this minus sign is omitted and you need to take the value as positive. And in that case, if you take it as positive, let me check out what we'll be getting. So I'll be getting it as 280 into 1000 plus 822.57 into 1000 divided by 2 into 90.464, right? So I'm getting some value 6093. I need to take square root of this, so square root of answer is 78.06, right? So that is what I have written here, 78.06, and we know that di is equal to 0.8 times d naught, 0.8 times d naught, right? So 0.8 times d naught is 62.45. So these are the two values of the diameters, right? So be careful while simplifying a very important problem from your exam perspective, because here you are getting a fourth order equation, and how you are going to tackle that, that is the logic, right? So practice this problem, a very important one. Once again I'm stressing this. So practice this. In the next session I'll be coming up with a different kind of problem, a unique kind of problem. So be ready for a challenge, because I am asking you something in the next problem which is a bit tricky to tackle, right? So you just revise your basic concepts. Till then I'll be formulating a new problem for you people and getting it in the next session. Have a nice day. Take care.